doing? Happy weekend. This is my giraffe. I got it in Haiti. I got a big one and then a little one. Isn't it cool? I kind of love it. The giraffe is going to sit here and learn geometry today. So you sit there, giraffe. Giraffe doesn't stand up very well, so giraffe can look that way. All right, you had to do the evens, written, page 78. So I have some of the odd answers up here, but we're not going to go over the odds right now. But, okay, so the directions said use the given information to name the segments that must be parallel. If there are no such segments, write none. So number 2, we're going to jump right to 2. 2 equals 10. These two angles right here, they're not same side interior, because if this angle was parallel with this angle, then that whole angle would have to be same side interior. They're equal. It doesn't tell us anything. So the answer to this is none. Number 4 says angle 5 is congruent to angle 8. If angle 5 is congruent to angle 8, oh look, if we extend this one and extend this one, then those two would be alternate interior, and therefore NT and AU are parallel. Okay? Number 6. 6 is equal to 3 is equal to 90. 6 is here, equal to 3, that doesn't tell us anything, is equal to 90, doesn't tell us anything. The answer for 6 is none. 8. 8 says...
What about 7?
I'm only doing evens.
Oh.
AU is perpendicular to OT. AU is perpendicular to OT. Did I forget to write O? O would be here, so OT. So these two are perpendicular. And then NT is perpendicular to OT. NT is perpendicular to OT. So these two are perpendicular. So number 8, AU is parallel to NT. These two lines are perpendicular to the same line, and these two must be parallel because they're both perpendicular to the same lines. So AU and NT are parallel. I don't know if that's what I said at the beginning, but okay, skip down to number 10. The measure of angle 2 equals the measure of angle 5 equals the measure of angle 8. Measure of angle 2 is here. Measure of angle 5 is over here. Well, and then equals the measure of angle 8. Well, I notice if this is my, if these two lines are parallel, then those would be alternate interior. So AT must be parallel to RU. Same thing over here. If these two lines are parallel, then these two would be alternate interior. So NT must be parallel to AU. So I wrote RU and AT, and then AU and then NT are both parallel, and that's because both of them are alternate interior. Here's the proof on number 11. We'll skip that. 12. I don't like these questions like on number 12. I'm going to read you what the book says for an answer. Through a point outside a line, there is at least one line perpendicular to a given line. Through a point outside a given line, there is at most one line perpendicular to the given line. I'm not a big fan of that question, so if you got confused, don't worry about it. 14 was challenging. I really had to think on 14, especially for this angle right here. I'm going to show you how I did it. The first thing I did, the blue angles weren't given in your book, but the first thing I did is looked at all my angles and said, okay, I got to fill in the missing angles. So I knew that was 180 degrees, okay? So I filled in 75 because 55 plus 50 is 105, and therefore 180 minus 105 is 75. These right here, if I added these up, 60, 45, and 50, added all those up, and I got 155, and then I subtracted 155 from 180, and I got that angle's 25. Then what I did is started to look at which angles were congruent. And these two are congruent. So if these are two are congruent, then these two lines must be parallel with this line being the transversal. So NSO is congruent to XOS. Those are both 25. So XO and SN are parallel. And then I noticed, I started playing around with the numbers a little bit, And I noticed that this angle right here and this angle right here have the same measurement. YOP, if you add those two angles up, is 105. HSO, you add those two up, is 105. So those two, this angle and this angle, are equal, so therefore this one and this one corresponds together, which means YO and HS must be parallel. This was not an easy question, but I really liked it and I had fun doing it, but I didn't get it immediately. I had to think about it. Okay, just so you know, my book doesn't give me all the answers, especially with the proofs. So I have to think, and I usually do these questions just like you do. I don't use my teacher book because I want to make sure I understand it and I can do it before I teach it to you. So I don't know, I'm having fun. I hope you are. Okay, this was another challenging one. Actually, this was the one that was challenging. That one wasn't as challenging as this. This was the one that was really challenging. I drew the lines in pink and blue because the lines there were color coded. It said if the pink ones or the red ones are parallel and the blue ones, then what do you know? Okay, so it did take me a few minutes to figure this one out. But if these two lines are parallel, I know these are alternate interior and they must be equal. So I set it up, 3x equals 105. Divided by 3, and I got x equals 35. So if x equals 35, that whole angle equals 105. Those are alternate interior. Okay, then what I did was I know x equals 35, okay? So I extended this line down and let's see. I gotta figure out how I did this. X over here, I knew these two lines were parallel. This is what I did. I knew these two lines were parallel, and I knew this was a transversal, so I knew that these were alternate interior, so they must be equal. So I said that and that were alternate interior. That must be x. X I already know is 35. So then I added 105 plus 2y plus x equals 180. I usually do it all like equals 180, but I didn't have enough room, so I had to put 180 on the left. Doesn't matter if you have an equal sign in between. 180 equals 105 plus 35 is 140 plus 2y. Subtract 140 on both sides, you get 40 equals 2y. Divide by 2, y equals 20. So the answers were x equals 35 and y equals 20. This was the most challenging problem on the page, but it was fun. Okay, 18 says, given angle 3 and angle 6 are congruent, so I drew in my little congruent signs. We know that these two are going to be congruent because they're vertical angles. But if those two are congruent, then these two lines must be parallel, PQ and RS, because if alternate interior angles are congruent, then the two lines that make them are parallel. So PQ is parallel to RS. And then therefore, if those two lines are parallel, then these two are also alternate interior. So angle 1 is congruent to angle 4, alternate interior angles. Okay, I've got two proofs. The first proof, I'm going to have to stand up on a chair. K is perpendicular to T, and N is perpendicular to T. First thing I did was I started drawing other numbers for angles, but I'm like, you know what, I probably don't need them. So you didn't, so I ended up erasing them, and I changed a couple of my steps. I have to prove that K is perpendicular to N. Okay, by the way, keyword is giraffe. Hi, Kelly. Kelly just got home from Dunkin' Donuts. Now she's running away. Okay, back over here. Okay. K is perpendicular to T, N is perpendicular to T, that's given. Okay, the next step, I had to determine that T was a transversal. T is a transversal to K and N. I just said it's a transversal. Definition of a transversal, if a line cuts two other lines, then that's what a transversal is. I said angle 1 and angle 2 are 90 degrees, definition of perpendicular lines. So therefore, angle 1 is congruent to angle 2 by substitution. And then K is parallel to N because if two lines are cut by a transversal and corresponding angles are congruent, then the lines, that's his lines, are parallel. And that's what I had to prove. Last one.
I put the cookies in.
Okay, I'm filming.
Hee hee.
Oh. Say hi, Caitlin. Okay. Given. Did I say the key word was giraffe? Yeah, I did.
No, you didn't.
Did I?
No,
Oh,
but no, it is.
Oh, All right.
Just
Given C is perpendicular to 3. Okay, C is perpendicular to 3. I mean congruent, I said perpendicular. So I drew in my little congruent signs. Those two, I'm already looking. I extended these lines. Oh, look, these are congruent. I know these are going to be parallel. Okay, CD and BE are going to be parallel because those two lines are congruent and these are corresponding. BE is perpendicular to DA. BE is perpendicular to DA. I have to prove CD is perpendicular to DA. Okay, down here. That's all given, not saying it again. CA is a transversal to CD and BE. CA is a transversal to CD and BE. Okay? Angle C and angle 3 are corresponding angles. That's what I said right at the beginning. Those are corresponding, definition of corresponding angles. CD is parallel to BE because if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So I know those are parallel. Then I put angle CDE equals 90 degrees. So this equals 90 degrees because these are same side interior. And if angles are same side interior, then they're supplementary. And 90 plus 90 is 180. So those are same side interior. And therefore, those two lines are, CDE is 90 degrees. CD is perpendicular to DA because definition of perpendicular lines, that was 90 degrees. I probably could have threw in an extra step in here. And I'll be honest, the reason why I didn't is because I kind of ran out of space. But I probably should have said angle CDE plus angle BED are supplementary because the same side interior angles of parallel lines are supplementary. I probably should have thrown that in there, but I didn't. I would accept this. Like I said, I just ran out of space. So what do I want you to do? We're going to be doing the odds in class on Monday. I want you to know that there is a test coming up. I think what I'm going to do is have you guys have a quiz on Tuesday on these new theorems. So I'm going to tell you what the new theorems are. Postulate 11, theorem 25, 26, 27, 28, 29, and 210. So very similar to the quiz you had last week. I'm going to give you a quiz on those theorems in postulate. And then on Friday, unless you want it Thursday, and we could talk about that on Monday, on Friday you will be having a test on this section, like the beginning of chapter 2 up through page 69, I think. Okay, so I hope you're getting this. What I was thinking about doing is at lunchtime, if you would like to come join me for lunch, I will eat my lunch with you in my room and we can go over some of these problems. I know some of you can't stay after school or whatever, and I would love to do that with you if you're not understanding, and I just want to be able to help you guys. So I want you to like geometry. I know you all don't right now, but maybe you will someday, and who knows, maybe one day you'll be teaching geometry to my kids. You never know. Bye.